So this question is just a reminder of how we learn to get the solution to a system of equations. So we've got two different equations here, and we want to get the solution, which is in the form xy. We're looking for a solution to this system of equations without having to graph, but instead we're using elimination. So we want to figure out what is going to be the easiest variable to eliminate. In this case, I can see that I have 0 pairs with my y's right here, because I've got a positive and a negative 3y. So because of that, those are the ones that I'm going to try to eliminate. So I'm going to add together my two equations here. So I'm going to say 2x plus x, that's going to give me 3x. And then I have the 3y and negative 3y plus 3y. Those cancel each other out, so I have 0. Then I have 12 plus 6. So I bring that equal sign straight down, and 12 plus 6 gives me 18. So from there, I'm going to get rid of that 0, because I really don't need to have the 0 there. It doesn't help me. It doesn't change anything. So I'm just going to write this as 3x equals 18. So I have 3x equals 18. So to find x by itself, that's what I'm looking for, is to get x by itself. So I'm going to divide by 3 to get the x to be by itself. When I divide by 3, the 3's cancel, and I'm left with x, bringing that straight down, equals 18 divided by 3 is 6. So I've got my x value, and I still need to get my y value, because remember, my answer is in the form xy. So I've got my x value. So let's find the y value. Well, to find my y value, I'm going to plug my x value into either one of these equations. Now I like to choose the one that's got the smallest numbers, so I'm going to go with this one. This one has the smallest numbers. You can go to either, you're going to get the same answer, but I'm going to plug my x value in for the x that is here. So here we had x plus 3y. We had x plus 3y equals 6. And we had that because we didn't know what x was at this point, but we just figured out that our x is going to be 6. So instead of saying x plus 3y equals 6, I'm going to say 6 plus 3y equals 6. I want to get the y by itself now. I've already gotten my x, and let's try to get the y by itself. So I'm going to subtract 6 on both sides to do that. From there, those cancel out, so I have 0 plus 3y equals 0. I don't really need that 0 there, so I just have 3y equals 0. I want to get the y by itself, so to do that I'm going to divide by 3. When I divide by 3, my 3's cancel out, so I have just y, and 0 divided by 3 is just 0. So I've got my x, I've got my y, so then my solution now is, remember it's in the form xy, so my x was 6, and my y is 0. Now, this was just a reminder of what we've been doing, but let's take a look at if I don't have 0 pairs to cancel out. So if I look at this problem, let's let this focus. If I look at this problem, what I have is 2x plus 10y equals 2, and 3x minus 5y equals negative 17. Well, there's no 0 pairs here. 2 and 3 are not going to cancel. 10 and 5 are not going to cancel. So I need to figure out how I can cancel some of these variables here so that I can simplify it the same way I did on the last one. Well, I know that 10 is just another multiple of 5. So if I wanted to create a 0 pair here, then I could multiply 5, this negative 5, by 2. But if I do that, I'm going to change the whole equation. So what I do to keep it balanced is I'm going to multiply this whole equation by 2. I'm doing that so that I can create a 0 pair here where the 5 is going to cancel. I want to be able to cancel the y values. So when I multiply this by 2, I end up with 2 times 3x gives me 6x. 2 times negative 5y, that's minus 10y, and then 2 times negative 17, so that's equal to negative 34. So now I've got this as my equation. So I'm gonna just rewrite this one. I'm just gonna bring this equation down and rewrite it, where I had 2x plus 10y equals 2. Now I've got my zero pairs here. I've got my zero pairs plus and minus 10y, plus and minus 10y, so I can solve this now. So I'm going to add them together. 6x plus 2x leaves me with 8x. Negative 10y plus 10y, I have 0. Negative 34 plus 2, that's different signs, so I'm going to subtract. So 34 minus 2 is 32. And keep the sign of the larger number, so keep that negative sign. So now I'm going to rewrite this because I don't need to have plus 0. So I have 8x equals negative 32. Once I have that, once I've done that, I'm going to divide by 8 on both sides. Those two are going to cancel, and I'm left with x equals, well, negative 32 divided by 8 is negative 4. So I've got my x value. I still need my y value. So I'm going to take this negative 4 and I'm going to plug it into one of my original functions. I'm going to plug it into this one because, remember, I like to have smaller numbers here. I like to do whatever I can to make this as easy as possible. So I'm going to plug my original equation here was 2x plus 10y equals 2. So I want to, I had x here, but I know now that x is negative 4, so I don't need to say 2 times x anymore because I know x is negative 4. So I'm going to say 2 times negative 4 plus 10y equals 2. So 2 times negative 4 is negative 8 plus 10y equals 2. I'm just bringing everything else straight down. Now I want to get this 8 to go away because I'm trying to get my y by itself. So to do that, I need to get rid of this 8. So I'm going to add 8 because I have negative 8. So to cancel it out, I do the opposite. So I have negative 8, so I'm going to add 8 to cancel that out. When I do plus 8 on the left side, I need to do plus 8 on the right side. So what I end up with, these cancel, and I have 10y equals 2 plus 8 is 10. So I need to get my y by itself. So I am going to divide by 10 because this is saying 10 times y. You cancel out multiplication using division. So if I divide on the left, I need to divide on the right. Those 10s cancel, and I'm left with y equals 1. So I've got my x, I've got my y, so I just need to write my final solution as negative 4, 1. So if you notice, the only thing we really did different here is we needed to create a zero pair since we didn't already have it. So I created this zero pair by multiplying by 2. That was the easiest way I could create a zero pair. I had positive 10, so I wanted to make a negative 10. In order to do that, I needed to multiply by 2. So let's take a look at a third problem here. We're going to do the same thing. Now, if you want to, you can pause the video and try it on your own, or you can watch me do it again. So I've got 3x minus 7y equals 2, and 6x minus 9y equals 9. Well, I don't have any zero pairs, so I need to create a zero pair. So I'm going to look at what is the easiest zero pair to create. Well, 7 and 9, they're not multiples of each other, but 6 is a multiple of 3. So if I wanted to create a zero pair, well, I have a positive 6 here, so I want this to be a negative 6. So how can I make 3 into negative 6? Well, I can multiply by negative 2. If I multiply by negative 2, then I end up getting negative 2 times 3x is going to give me negative 6x. But remember, I have to multiply this across the whole equation because I need to keep the balance. So I have negative 2 times negative 7. Negative times negative is going to be plus. So negative 2 times negative 7y is going to be plus 14y. And then I have negative 2 times positive 2. So that is equal to negative 4. So now I've got my 0 pairs here. I've got my 0 pairs with positive and negative 6x. So I can cancel out those two when I add them together. So 6x plus negative 6x, that gives me 0. Then negative 9 plus 14, negative 9y plus 14y, that's going to give me a positive 5y, because remember, different signs, so you subtract. Keep the sign of the larger number. The positive is large, the 14 is larger, so it's positive. And that's equal to 9 plus negative 4 is positive 5. So now I don't need that 0 there, so I'm just going to write 5y is equal to 5. And I'm trying to get the y by itself. When I do that, to do that, I need to divide by 5, because what I have here is 5 times y equals 5. So to cancel out multiplication, I divide. If I divide on the left, I need to divide on the right. When I do that, those cancel each other out, and I'm left with y equals 5 divided by 5, which is 1. So I've got my y value first this time, so I'm still going to need my x value. So to do that, I'm going to plug my y value of 1 in for my y that was here in the original equation. So my original equation, I had 3x minus 7y equals 2. But remember, we didn't know what y was, but we just solved for y. So we know that y is 1. And since y is equal to 1, I can replace this y. So I'm going to say 3x minus 7. It was 7 times y originally, but I know that y is 1. So instead of saying 7 times y, I'm going to say 7 times 1. And it's still equal to 2. So I can keep going. 3x minus 7 times 1 is just 7, and that's equal to 2 still. So now I want to try to start getting this on its own. So I have to get rid of that 7 so I can get my x by itself. I'm trying to solve it for x. So I have minus 7, so I'm going to add 7 to cancel that minus 7 out. If I add 7 on the left, I need to add 7 on the right. So when I do that, I'm left with 3x. The 7's canceled each other out, and that's equal to 2 plus 7 is 9. Again, I'm trying to get my x by itself, so I'm going to divide by 3, because I'm saying 3 times x. To cancel out multiplication, you divide. So I'm going to divide by 3. If I divide by 3 on the left, I've got to do it on the right. So ultimately, these 3's are gone. I have x equals 3. So now, remember, I need it in the form xy, right? So even though we found y first, we still need to write x first. So it's x is our 3, and y is 1. So our solution to this system is 3, 1. Let's try another one. So on this one, I can get rid of either one of these. So let's try to get rid of our y's. So I know that 2 is a multiple of 1, right? 1 goes into every number. So I know if I just multiplied this, I want to create a 0 pair, remember. So I'm going to multiply this whole equation by negative 2. I didn't leave myself a lot of space there. So I'm going to multiply this whole equation by negative 2. But when I do that, I've got negative 2 times x, that gives me negative 2x. I've got negative 2 times y, so that gives me minus 2y. And then negative 2 times 7 is equal to negative 14. So I just multiplied my negative 2 times each of my terms here. The negative 2 times x gave me negative 2x. Negative 2 times y gave me negative 2y, or minus 2y. And then negative 2 times 7, that gave me the negative 14 here. So now I've got these two equations that I can add together. So I'm going to add these together, and look what happens here. I've got 2x minus 2x, that gives me 0. I'm sorry, 2x plus negative 2x, that gives me 0. I've got 2y plus negative 2y, so I've got another 0, and that is equal to 6 plus negative 14, that gives me negative 8. Because remember, different signs subtract. 14 minus 6 is 8. And keep the sign of the larger number, so it's negative. So that says that 0 equals negative 8. But think back to when we were doing solving equations. This is never true, is it? 0 does not equal negative 8. This is never true. So because this is never true, we have no solutions, and we can stop there. Oh, no solutions. We have no solutions here because 0 equals negative 8 is not true. When you get a statement that is not true, then you have no solutions. So let's try another one. Try one more. This last one, what we have here is 2x plus 2y equals 6, and x plus y equals 3. So on this one, I'm going to try to get my 0 pairs. So I'm going to get my 0 pairs by multiplying this second equation by negative 2, because if I multiply this by negative 2, these two will cancel each other out. So if I multiply this whole thing by negative 2, then I'm distributing that to negative 2. So negative 2 times x, I get negative 2x. Negative 2 times y, I get minus 2y, so negative 2y. And then negative 2 times 3 is going to give me negative 6. So I've got my original equation that's still there. So I'm going to bring that down so that it's easier to see what I'm doing here. So I'm going to rewrite that where I have 2x plus 2y equals 6. So these are the two equations that I'm going to add together. So I've got negative 2x plus 2x, that gives me 0. Negative 2y plus 2y, that also gives me 0. And then negative 6 plus 6, that also gives me 0. So what I end up with here is 0 equals 0. Well, 0 does equal 0. That is always true. That is always true. So when we have something that is always true, if you remember back to solving equations, if the statement is always true, that means that we have infinitely many solutions. Infinitely many solutions. It doesn't matter what I plug in for x and y, I am always going to have this same line. Now when I have infinitely many solutions, that means if I were to look at a graph of the two, it would just be one line. I don't have two different lines here. These two equations make the same line. So that's why there are infinitely many solutions, because every point on the line is the same. If I were to look back at my problem with no solutions, what I would have ended up with was two parallel lines. Two lines that are never going to touch because they have the same slope and a different y-intercept. So every time one of them moves, so does the other. They're never going to touch each other. And when you think back to what we were doing on the other ones, like this one, for example, the problem 2 we just did, we have two different lines. So one looks something like this and one looks something like that, and they have one point where they cross each other. Okay, hope that helps.